Welcome to The Explainer. You know all those smart predictions you see every day, the ones that just seem to work like magic? Well, today we're pulling back the curtain, because behind a lot of that magic is a powerful learning method, and we're going to break down exactly how it works.
All right, so here's our game plan for today. We're going to start with a problem you see all the time. Then we'll get into the core concept, learning with an answer key. After that, we'll look at the two main jobs it does, peek at one specific tool it uses, and wrap it all up with a good, honest report card.
Okay, first up, let's talk about a problem you probably dealt with, I don't know, maybe 5 minutes ago?
So how in the world does your email know what's spam? Or how does your bank flag a transaction that looks a little weird? It's not magic. It's a model that has been carefully taught to see patterns, and that teaching method is exactly what we're here to understand.
And that teaching method brings us right to the heart of the matter, a technique called supervised learning. Just think of it as learning with a cheat sheet, or an answer key.
Okay, so if you only remember 2 words from this definition, make them these: labeled data. This is the absolute game changer. We're not just chucking a bunch of random information at the AI. We're giving it data that already has the correct answers attached. This ground truth is basically its teacher.
Seriously, this is the best way to think about it. It's like we're giving the AI a gigantic stack of flashcards. On one side, there's a question, like an email or a photo, and on the back, the correct answer is already written down. This is spam, this is not spam, this is a picture of a cat.
And it really all just boils down to this super simple but incredibly powerful 3-step process. First, you feed the model thousands, maybe millions of these flashcards. Then the model just starts to figure out the patterns. It connects the dots. And finally, once it's all trained up, you can show it something totally new, something it's never seen before, and it can make a really solid prediction. So supervised learning is really good at answering 2 main types of questions. Let's tackle the first one, which is all about sorting things, putting them into the right buckets.
And this slide breaks it down perfectly. You've got 2 main branches. On one side, there's classification. Think of it like a really smart sorting machine. Its whole job is to say, is it A or is it B? Then, on the other side, you've got regression, which is more like a calculator. It's not sorting, it's predicting a specific number.
And you see classification in action everywhere. Is this email spam or not spam? Is this credit card charge fraudulent or is it legit? Is this customer going to leave or are they going to stay? You get the idea. The answer is always one of a few clear-cut options.
And this whole sorting thing can be super simple, right? Just 2 choices, like pass or fail. We call that binary classification. But it can also get way more complex, like trying to identify different types of animals in a photo. Is it a cat, a dog, a bird, a fish? That's when we call it multi-class classification.
Okay, so that's sorting. But what happens when the answer you need isn't a simple category? What if you need an actual number?
Well, that's where regression comes in. It helps us predict things on a continuous scale. We're not asking hot or cold. We're asking, what's the temperature going to be tomorrow? Exactly. We're not asking high sales or low sales. We're asking, what's the predicted price of this house? It's all about forecasting a specific quantity.
So this all sounds great, but how does the learning part actually happen? Like, what's going on inside the black box? Well, there are a bunch of ways, but let's peek inside the toolbox at one really popular algorithm that's surprisingly easy to understand.
We're going to look at k-nearest neighbors, or KNN for short. And I know, the name sounds a little technical, but trust me, the core idea is something you probably do in your own head all the time without even realizing it.
This is it right here. The whole idea is that you can tell a lot about something just by looking at what's around it. You know the saying, birds of a feather flock together? Well, in the world of data, things that are close to each other are probably similar.
And this dog breed example is just perfect. Imagine we have a big chart with height and weight. We plot all the dogs we already know. The Huskies go here, the Golden Retrievers go over there. Then we add a new mystery dog. What does the algorithm do? It just looks around. It finds its closest neighbors. If the K, let's say the 4 nearest dogs, are mostly Golden Retrievers, then what's our best guess? It's probably a Golden Retriever too. Simple, but so effective. But, just like any tool, supervised learning isn't a silver bullet. It's not some magic wand. It is incredibly powerful, for sure, but we need to have a clear-eyed view of its strengths and its weaknesses.
So here's the report card. On the one hand, these models can be amazingly accurate, and you can use them for almost anything. But they have a huge weakness. They are so hungry for labeled data. And getting that data, cleaning it, labeling it, that's expensive, and it takes a ton of time.
And here's the really big one. If our data has human biases baked into it, and let's be real, it often does, the AI is going to learn those biases, no questions asked.
So when we circle all the way back, we see that supervised learning is this quiet, powerful engine running in the background of our digital lives. It's the reason your spam filter works, the reason you get that movie recommendation, the reason your bank can flag fraud before it happens. It's everywhere.
And that leaves us with a pretty big question to think about, doesn't it? This AI, it learns from our past. We are the ones providing the answer key. So that means we have this profound responsibility for the lessons it learns. The patterns it finds are just a mirror reflecting the data we show it, our history, our decisions, and yeah, our biases. So the real question isn't just what can the AI learn, it's what should we be teaching it?